Good afternoon, good evening. My name is Miss Barton. Some of your faces are familiar, so you do know me. But for those of you who don't, hello, hi. Guys, welcome and thank you for joining us at this exam prep conference. I hope that you're going to find something valuable in it. Just to make sure, does everybody have a summary booklet? It's the one that when you open up looks like this. Is there anyone who does not have a summary booklet? Okay, the next document should be the marking guidelines. We all have marking guidelines. Okay, and then lastly we have the questions booklets. Okay, so it seems like everybody has their documents. Just before we actually begin, I just want to explain to you what each document is. Firstly, the goal of today's session is not for me to teach you guys physical science. The assumption is sort of that you guys, having written your prelim exams, have gone through all of the content and you have a fair understanding of physical science. So I'm not going to try to teach you guys physical science. Instead, I'm going to prepare you for your exams. And we're going to look for those common mistakes that you make that are denying you your marks. Maybe you're a 70%er, want to get into the 80s. Or maybe you're in the 50s and you want a 60, right? My idea is that everyone at least wants a 60% because that's what the universities require, okay? So firstly, the first document is the summary booklet. If you open it up, you're going to see on the first page the cognitive levels, the different types of questions you're going to find in an NSC exam, and a breakdown, an expanded version of those, okay? If you go on to the next page, you're going to see all of those science skills you guys need to know, independent variable, dependent, controlled, so on. And next you're going to see a whole lot of summaries. The next document is the questions booklet. Inside of this document, you're going to see a very familiar past paper. How many of you are from Gauteng? Quite a number of you. And if you wrote the government provincial paper, then this is the one you wrote the other day. Okay, so that is there, right? And we're going to be looking at a few questions from there. Again, I'm not going to be working through them per se. I'm going to show you guys where you are going wrong. And then the last one is a marking guideline. Okay, and that is what we use to mark your exam. Alright, so the reason why it's 3 different booklets is so that you guys can distinguish between or use them at the same time. Okay. So guys, let us begin. For some reason, no matter how hard I try, I can never just start with what I'm supposed to. And so before I even speak about physical science, I'm going to speak about this quote that I have on the screen. Okay, it says, you don't always choose the path you walk in life, but you always choose how you walk it. And I know, guys, that a lot of you didn't choose to take physical science. Maybe your parent, your guardian forced you to take it because that's what clever kids do, right? Then there are some of you who decided yourselves to take physical science, and you have now reached the point in your academic career where you realize, yo, I don't like this subject. It was a bad decision. I don't like this one. In fact, I hate it. I wish I never made this decision. Okay, and that's actually very, very common. And at this point, you don't even know if you decided on this path or if it was your ego a long time ago that decided on it for you. But you're here now, and I want to say to you guys, yes, here's the path. You have to walk the path. You need to write these exams. You don't have a choice. But always remember, when there's a path that you have to walk and you have no control over the path, you can choose how you walk it. So you guys are here now. You're taking physical science. Let's walk this path as best we possibly can. Okay, then over here I have an image of a sailboat, right? And I want to say that each of us are in a little sailboat of our own. We're on the ocean, and like today outside, it's cold and the wind is blowing, and we have no control over that. But the fact is that if you're in a little sailboat and you want to go north, and the wind is blowing you towards the south, what you would have to do is change the set of your sails so that you can use the wind to arrive at your destination. So guys, I know some of you or all of us are from different backgrounds. You don't always have the same resources that everyone else does. Maybe you don't have Wi-Fi at home. Maybe your parents have never gone to university or haven't finished high school and they don't know how to support you. But the reality is, what we have is what we have. And what we need to do is take what we have and turn that, in Jim Rohn's words, into the miracle of our future. So, right now, you see how your sales are, you see where you want to go, the wind is blowing, it's a cold day, the exams are on their way. Change the set of your sails. Change your attitude, change whatever is in your control so that you can ultimately arrive at your destination. But stop focusing on the little things that are outside of your control. Maybe your teacher is not so great. Maybe you're in a school where X, Y, Z, not in your control. Focus on what is in your control, your attitude, your timetable, your study timetable, your study habits, how often you're on Instagram and TikTok. And in doing so, you'll ultimately arrive at your destination. Okay, so guys, like I've said, the goal today is not for me to teach you physical science. Yes, you'll learn a little bit about physical science along the way, but the goal is for me to point out those mistakes that you commonly make. And what is nice is that a lot of you are from Gauteng and did write the paper that you now have in front of you. So you'll easily start to see the common mistakes that you make. And I want you guys to realize that it's not just about knowing the content. It's good if you know physical science. It's good if you understand physics and chemistry principles. But you also need to know how to write an exam so that you can get full marks. Okay, so that is our goal for today. So on the first page in that summary booklet, you're going to see a breakdown of the cognitive levels. Okay. If you are at the winter school, I would have gone through this with you before. If you weren't, now's your opportunity to maybe see it for the first time. Or if your teacher has already told you about the cognitive levels, then I'm here to remind you. Okay? So, in every physical science exam, whether it's an IEB exam or an NSC government paper, you're going to find level 1 questions. Okay. Level 1 questions take up 15% of your paper. And these are questions that require you to recall something. You memorize and then you vomit it onto your page exactly the way it was in your exam guidelines or in your SAGS document if you're an IEB learner. Normally the recall questions are all of those definitions, which I know you guys despise learning off by heart, but you really need to, because guys, 15% is a big percentage of your exams. So please stop neglecting definitions. Learn them word for word. I know that it seems silly. Why learn it word for word? When you look at those definitions, you'll start to realize that there are key words in those definitions, which when left out, make the definition nonsensical, according to the science. Words like isolated system, vector sum, all of those terms are very important. And so we tell you guys to learn them off by heart, not because we want to make your life difficult, but because it's the best way to ensure that you write down those definitions accurately. Okay, so that is 15% of your paper. Next, you're going to see level 2 questions. These are questions that require understanding. And whether you're an IEB learner or NSC learner, these are going to take up 35% of your paper. Now there is a slight difference, or I've learned that there's a slight difference between how IEB defines your understanding questions and how NSC does. So if you try the different question papers, you'll see they're a bit different. The main difference is that NSC, we tend to say that all calculations are level 3 questions. IEB tends to say that if it's a one-step calculation, it's an understanding question. But to give you guys an understanding of what an understanding question is, if you look at something like a free body diagram, if I ask you to draw a free body diagram, you read through content, you comprehend it, and you tell me what it is that you saw. That is an understanding question. If I say to you the friction is going to increase, tell me why. You are showing me how you understand the science in words. Normally, if it's in words in a physics paper, it's an understanding question. Then we have the application and analysis questions. 40% of your paper. And if you're writing a government paper, what we have seen is that in the past 3 years, if I'm not mistaken, there was a little bit more than 40% of the paper that was application and analysis questions. Here I'm talking about your paper 1 exam. So guys, you do really want to focus on those calculations. Multi-step calculations, make sure you know how to do them, because 40% of your paper is going to be those types of questions. And lastly guys, we have those questions that you guys worry about unnecessarily, the level 4 questions. A level 4 question is supposed to make you evaluate and judge a situation. So in my opinion, those questions that ask you, will it increase, decrease, remain the same, and explain why, that tends to be an evaluation question, because you're evaluating the situation and coming to a conclusion based on your judgment of the situation. But people vary, okay? If you are asked to create something, so let's say I say to you, we are going to the moon. I want you to design an experiment of how we are going to measure the gravitational acceleration of the moon. You've never seen this experiment before, so you are creating or synthesizing something new. But that is only 10% of your paper. So what does that mean? It means if you decide right now that you're never, ever, ever going to attempt a level 4 question, you can still get 90% for your exam. Okay, so I don't want you guys to focus too much on these or worry too much about them. You make sure that you master all of those definitions, understanding questions, and that you're able to apply yourself in different types of calculations. Guys, if at any point you have questions, please just feel free to put up your hand and I'll answer them. Okay, now, if you look at the different papers or the physical science paper for IEB versus CAPS or DBE, the department papers, you're going to see there is a slight variation in the percentage of each topic. So if you are writing the government paper, mechanics is going to make up approximately, I'll tell you the percentage now, approximately 43%. So this is 43% of your paper. So what that means is, for those of you that don't like Newton's laws, don't like momentum and impulse, vertical projectile motion, work, energy and power, if you decide to skip those topics, you are losing a total of 43% for your paper. Then we have electricity and magnetism. That is approximately 37% of your paper. So the major topics you want to ensure you know is mechanics and electricity, which is your electrostatics, electric circuits, electrodynamics, and AC current. And those tend to be the more challenging topics, but as you guys can see, when we put the numbers in front of you, you begin to understand that they are very, very important. A lot of you like waves and the Doppler effect because it tends to be a little bit easier, but that's only about 10% of your paper. You like the photoelectric effect because it tends to be a little bit easier, but that's just 10%, it amounts to 10% of your paper, okay? The IAB learners, you guys do not do the Doppler effect, but you will see that what we do in mechanics tends to be more than 50% of your paper. So what does this mean? It means if you are an IAB learner, you can make very good use of question number 2, 3, 4, and possibly 5 of the DBE papers. If you are a DBE learner, so if you are writing a government paper, I beg you guys, please go and try IEB papers. They are available on the internet. And what I as a teacher have done in the past is, I look at those IEB questions, and I take questions from those and adapt them to set my own exams. So there's a lot that you can learn from each type of question paper. The biggest difference is in how we mark, okay? You guys are going to see on that summary page, there is an expansion of all of the different topics. If your teacher has skipped red and blue shifts, please make sure that you study that. And atomic spectra in matter and materials is also very important. Okay, so that's all of the admin. I'm now going to start to talk about your paper. In the past, when I went and I marked exams, what we found, grade 12s, is that a lot of people skip multiple choice. Please, no matter what, you guys never skip multiple choice questions. You can guess, but I also beg you to not guess B and C actually, all the time. For some reason, there's a group of teachers, it seems, that says, we like to hide the multiple choice questions, so your answer is normally going to be B or C, so choose B or C. The fact is that the people who set the papers have realized this trend. So guess what we do now? We make the answer A and D, and we catch you guys out. So please, you have to know your content and you have to apply yourself. If you need to guess, well, you can choose. You can choose if you're going to listen to this rule or not, okay? But please never leave multiple choice questions unanswered, okay? Then please always make multiple choice or write multiple choice on the first page in your answer booklet. I want you guys to please remember that it is not your teacher who knows and loves you so much who is going to be marking your paper. Your paper may be the 1000th paper that some teacher is marking, who does not know you and who does not value, love, and appreciate you, okay? So you guys must make sure that you write your exam in such a way that that stranger can easily mark your exam. So you're always going to write multiple choice on the first page of your answer booklet, even if you're going to only answer it last. So get into your exam, write down question 1, 1.1, skip line, 1.2, skip line, 1.3, skip line. And if you want to get back to it later, that's fine. But write it down on the first page of your answer booklet, please. Of course, this doesn't apply to the IB learners because you guys have an answer booklet that you fill in, okay? Now, some of us are very anxious. I suffer from anxiety. I'm very nervous here as I stand in front of you, okay? And because we are so nervous, when we write our exams or at the beginning of the exam, when they say, it's reading time, you have 10 minutes. What some of you have found is that as you read, your heart goes doof doof. And then it goes doof doof some more, and by the time they say you can start writing, you want to fall over. Okay, if you're one of those learners who gets very anxious when you read through all of the physical science paper, then I want to say, you must never skip reading time. You can't afford to do so. But if reading time makes you nervous, dedicate it to multiple choice questions. Take your time to read each multiple choice question and decide how you're going to answer it. In that way, you're making good use of your time without your heart going doof doof too much, okay? But use your reading time. Lastly, for some odd reason, we always tend to skip multiple choice when we are studying. You have to practice multiple choice. What we have seen is that it's often the worst answered question or one of the worst answered questions in the exam. There's this big idea that multiple choice is easy, but it's not easy. You can get a level 1, 2, 3, or even a level 4 question in multiple choice. Okay, so on the note of multiple choice questions, if there are any of you who have never in your life seen a document that looks like this, that is filled with a whole lot of multiple choice questions, what I want you guys to do, I promise I'm not going to spam you, I want you to please send me an email. You're going to see my email address in the summary document. Send me an email address, tell me you're looking for the multiple choice questions, not now of course, alright? And then I will send them to you. With nothing else, except my best wishes, I can send those multiple choice documents to you. It's a whole lot of multiple choice questions per topic that you can try, and I'll send you guys memos as well. Okay, so that is multiple choice. Please stop skipping your multiple choice questions. On to Newton's laws. Guys, in your exam, there are a few questions which involve vectors. What I prefer that you guys do is, as soon as we say, you may begin, go and write down Newton's laws, momentum and impulse, vertical projectile motion, and a little bit sort of work energy and power and electrostatics. that there may be vectors, so you must not forget to choose one direction as positive and the other direction as negative, okay? You guys tend to forget that we are dealing with vectors and it is messing you up badly, okay? So in this question that you guys, or some of you wrote not too long ago, it says a toy train of mass 2 kilograms and a toy car of mass 1 kilograms are attached by a light inextensible string. The car train system is pulled up a rough slope, and you guys know the word rough should make flashing lights go on in your head. That implies that there is friction. There you go. And it's moving at a constant velocity, which tells us, there you go, F net equals 0, acceleration is 0. Okay, you can see you guys are in grade 12 now. You've been busy with this grade 11 work. Okay, so now, in the first question, it says, explain the term net force or resultant force. The biggest mistake you guys made was to leave out the word vector. And because you said it is the sum of all of the forces or the sum of all of the vectors, right, you lost your marks. Okay, guys, key word here. Let's say that we have a human being and that this human being is going to go on a trip. They're going to move 1 kilometer to the right, okay, positive x-axis to the right, and then they're going to move 1 kilometer up. And then I say to you guys, what is the distance that the human traveled? What are you going to say? There you go, you're going to say 2 kilometers. But if I ask you what is the displacement, you're going to say displacement is not the same as distance. In fact, in grade 11, you guys learned that when you have both x and y vectors, you cannot just add them. You're going to say, given that they're at right angles, our resultant is from the tail of the first to the head of the last, and you're going to use Pythagoras' theorem. This is a form of vector addition, right? We are adding, but not the way you normally would add in math. Not the same way you add money. In this case, we are adding using Pythagoras, and we would say that the displacement is the square root of 2 kilometers, right? And that is different. That is why the word vector is so important. So if you have any intention of going through this paper, whether you've written it before or you haven't, I want you to go and highlight the word vector, point it out yourself, because this is a definition that does come up once in a while, okay? Now, on to free body diagrams. I know you guys have been drawing them, but now you've become comfortable and you're starting to make mistakes, and maybe your teacher forgot to tell you that there's a new rule. So the department has decided, grade 12s, that if we are drawing a free body diagram for this toy train, then there's only one acceptable way of drawing it, and this is it. What some of you are still doing is you are taking the diagram and you are breaking it up into components. I'm sure IAB is still okay with that, I can't say for sure, but if you're writing the department's paper, you are no longer allowed to take this force and break it up into FG perpendicular, FG parallel, and take this force and do the same. If you do that, you're going to lose your marks. We are no longer allowed to submit for marks diagrams that contain components. Some of you also take your system of axes. So as you guys can see, we are currently on a slope. And what you guys do is you take that slope and you rotate it because it tends to make better sense to your brain. They take away your marks. Don't do that. Draw it exactly as it is, as though if you're going to draw it on the train as it is over here, okay? Other things that you guys do that causes you to lose marks, you make a tiny little dot, and then you say, there is T1, and there is the friction. There's a big, big problem there, because friction is parallel to the incline, and T1 is parallel to the friction. So what we do, we make the circle bigger, guys, okay? We're going to draw a big dot. And we're going to make sure that when we draw T1 and when we draw in that friction, that they are parallel to each other. Make the dot bigger, don't make the vectors do this, okay? Another thing, by definition, friction is parallel to the incline. So if we are talking about the normal force, by definition, the normal force is perpendicular to the surface. So how do I know if you've drawn the normal force correctly? I check to see more or less if these two vectors are at 90 degrees to each other. And if they're not, you're unfortunately going to lose marks. We don't care about how long your arrow is. That's up to you. But we do care about the angles. So please make sure that your angles are as accurate as you can possibly make them. I'm not saying you must bring a protractor, but as far as possible, make sure the normal force is at a 90-degree angle to the incline and friction is parallel. And again, no more components. You can draw the components for yourself, but when you are done, for submission, you draw this. Alright, now the next question said you had to perform a calculation. I'm going to skip that because I'm confident that you guys know how to do it. And I want to go on to question 2.4, which says, halfway up the slope, T1 brakes and the car rolls down the slope. Does the friction on the train increase, decrease, or remain the same? Explain the answer. Okay? This question has two parts. You need to write down a conclusion and you need to explain. The conclusion will make up 1/3 of your marks, but the explanation is something you guys struggle with. If you like math, you struggle with this question, and you are losing marks because of this question. Whenever you are asked a question in physics that requires you to come to a conclusion, increase, decrease, remain the same, the first question you're going to ask yourself is, what are they asking you about? And in this question, they are asking you about the frictional force, okay? They are changing something. On the car, or on this diagram, the tension force breaks, and suddenly our free body diagram changes from what it was to no longer having T1. And the question is, when you make that happen, what is going to happen to the friction force? My advice to you guys is, as soon as they go and they change something about the situation, go draw a new free body diagram, number one. Secondly, we've identified that they are talking about friction. So what you're going to do is, you're going to go to your formula sheet and you're going to ask yourself, how do I calculate friction? And you guys will agree with me. It's the coefficient multiplied by the normal force. So we know that friction is dependent on two things. Number one, we have the coefficient. And for some reason, a lot of people don't know what the coefficient is about. The coefficient is about the types of surfaces that are moving over each other. Is it silk on wool? Is it silk on plastic? Is it silk on a metal box? That is what determines the coefficient, the types of surfaces. And then we have the normal force, which you guys know is that upwards force perpendicular to the surface that is holding that object from falling into the earth, okay? So the question you guys should have asked yourself is, in this situation, what is the dependent variable, what is the independent variable, and what is it that is staying constant? As soon as I move or remove T1, I need you guys to understand friction does not change, because friction is only affected by the normal force, and given that the normal force in this case is only affected by Fg perpendicular and T2's y component, and those two things do not change, we know that the normal force in this question is going to stay constant, okay? I'm looking at this thing. I want to know what's going to happen to the friction, but it only depends on two things, the types of surfaces and the normal force. So I asked myself, does the normal force change? No, it doesn't. I asked myself, do the types of surfaces change? No, they don't. It's still the same object, the train, that is moving up this incline whose angle has not changed. Okay? So given that this also does not change, we can come to the conclusion that the friction force remains the same. Okay? Then we need to explain why. Frictional force depends on the coefficient and it depends on the normal force. So this is one of the answers on the answer booklet or in the marking guidelines. I would have expanded it a little bit more and I would have said frictional force is directly proportional to the normal force and it's directly proportional to the coefficient. I'm referring to two things that I'm finding inside of the formula. Independent, dependent, and the relationship between the two. Friction is my dependent variable. It is dependent on the normal force and the coefficient, which is the types of surface. Neither of those things change, and I state the normal force stays the same, and so does the coefficient, so I would add that in as well. And therefore, grade 12s, the friction force will remain the same. Okay, so if you understand this, you are always, when you're answering a question like this, you're going to find a formula, you're going to identify your independent variable, your dependent variable, your constant, and then you're going to state the relationship between the independent variable, dependent variable. This is how we tend to answer these questions. Yes, sometimes you might state a little bit more than needed because here the explanation is only out of 2 marks. But independent, dependent, constant, and the relationship, and you'll most probably get your marks in question by question 2.4. So what I want you guys to do now, just as a break from my talking, you're going to see if you take a few pages or page on in the one document, this one over here. If you go on and on and on and on and on, you're going to see that I've also inserted the November exam from last year. Now on page number 8 of this November exam, you are going to see question number 2. Similar to the Gauteng paper, because what we tend to do is we make the Gauteng paper similar to the previous year to see if you guys have learned the mistakes that the previous year made, right? What I want you guys to please do is read through the situation and then answer question 2.4 in the best way possible. Think independent variable, dependent variable, control, and whenever you are explaining yourself, please answer in bullet point form. Do not write a paragraph. Answer in bullet points. I'm going to give you guys 2 or 3 minutes. Alright, so unfortunately you have not done the whole question, and because of that there are going to be a few gaps in your understanding or your interpretation. But in this question they say there are 2 blocks, A, mass this, and B of mass that, and they're connected by a light inextensible string. The blocks are held at rest on a plane which is inclined at an angle of 35 degrees with the horizontal. A constant force acting parallel to the plane is applied on B as shown in the diagram. The blocks now accelerate up the plane and they give you the acceleration. Now in this problem, if you take a look at question number 2.2, it says draw a labeled free body diagram showing all the forces acting on A. I did not ask you guys to do that because I'm going to do it with you. If we're focused on A, then we would say block A has acting on it an upwards tension force. We have perpendicular to the incline the normal force, and acting straight down we have Fg. If you ever forget where Fg goes, when I was in university, my lecturer said, her teacher said, or a teacher did this, he was frustrated with them, so he spat on the board and he asked them, where did the spit go? And where do you guys think the spit went? Down. So Fg is always going to go straight down, okay? So, please remember that. Now guys, this is the diagram that you draw for submission. You're doing this so that the marker can give you marks. But whether you do it on the side and then draw a line through it, because you must draw a line through it, or you just draw it on your question paper, I hope you guys understand that you always must take it one step further and take this diagram for A. We're going to label it as A, and we're going to say there is the normal force, there's the tension force, and we're going to take FG and break it up into its components. We're going to have FG perpendicular, which is keeping this thing on the surface, and then guys we have FG parallel. Now I could draw FG parallel without completing the triangle because this is what I know. If ever I'm walking up an incline and I slip, I'm slipping because of FG parallel. This is the component of gravity that causes you to slip. So for those of you that have FG parallel pointing upwards, you are slipping up the incline, and that doesn't happen. Okay, FG parallel is always down, straight down the incline. Okay, so always, please, always draw yourself this version. Whether you're drawing it on the sketch, on the side and cancelling it out, you're going to need this to make sure that in your calculations, you include all of the relevant forces. Now the next mistake you guys make is, you only do what they ask you. You don't always do what you require. And you need to understand that you require a lot more than they ask. So please, my dear grade 12s, when you are done doing what they ask you to do what you need to do to get your marks. And what I mean by that is, go to your diagram and please go and draw, whether it's on this, on your question paper, on the side, somewhere, but cancel it out if it's on your answer booklet. Please draw a free body diagram for block B so that you understand exactly what is happening with block B. If they tell you this force is force F, please don't go and label it force A, force applied. They are telling you it's F, stick to F. If they don't tell you, you can use just F or FA, although we prefer that you just use F. Then we know on this object, we also have a perpendicular force, normal force. We're going to have FG straight down, which we can break up into its components. FG perpendicular, and straight down we have FG parallel. There's also a tension force. Now I'm not going to go and fit in that tension force like that, because then I'm going to lose my marks. In need, I make the circle bigger, so that I can ensure that the tension force over there is straight down. And I don't remember, there is also a frictional force, and in this case, our frictional force will be straight down as well. Okay, have I analyzed this correctly? Does anyone disagree with what I've done? What did I do wrong? There's no friction. I see. Thank you. So on this one, there should be friction. And over there should be friction as well. Are we happy now? Yes. Okay, great. Alright. So that's the scenario, and we're going to work on from there. But again, if you are doing this on your answer booklet, you're going to cancel this one, you're going to cancel that one. This one because we no longer give you marks for it, and that one because it was not asked of you. And you never want a tired marker to mark the wrong thing. Okay, so please cancel that. Now based on that, when we get to this question, after we've done all of the pretty calculations and we've gotten our marks, they now say the angle that the plane makes with horizontal is now decreased. Okay, and they say, how will this change? Kinetic frictional force acting on block A, choose from increases, decreases, or remains the same, and then explain the answer. Now, I tend to always first analyze before I come to a conclusion. In other words, I tend to first do this before I actually answer the first question. What are they asking us about? Friction. Okay, so given that they are asking us about friction, what you should have done when you attempted this question is go to your formula sheet. By the way, there's a formula sheet at the back of the summary booklet. But you go to your formula sheet and you say, friction is equal to the coefficient, this is kinetic friction, multiplied by the normal force. Now we see this pretty thing called friction that we are interested in depends on two things. Number one, the types of surfaces that are moving across each other. And number two, the normal force. So let's ask ourselves the easiest question. Do the types of surfaces on the surface change? No. So that's a constant. That's a controlled variable. And we're going to mention that just in case they want us to, because they can be funny. Sometimes they want it, sometimes they do, sometimes they don't. And it confuses us and we don't know what to do. Okay, so rather we're going to mention that this thing is kept constant because the types of surfaces stay the same. Now we say to ourselves, something did change. They said that this angle is going to be decreased. Now, because we are dealing with forces on an angle, we know that if we are required to calculate the normal force, looking at this sketch, if they required you to calculate the normal force, for this diagram, we would say the normal force is equal in magnitude, but opposite in direction to Fg perpendicular. And how do we calculate Fg perpendicular? We say the gravitational force multiplied by cos theta. There you go. And you see that cos theta, it has a theta in it, and that theta is the angle which is changing. So we should realize our normal force is going to be affected. And whether you just understand how it's going to change mathematically, or you go and work it out for yourself to understand, we know that this thing is going to be impacted. So in your answer, I want to know from you, I'm talking about 2.4.2, I want to know that the coefficient is going to be constant because the types, sorry for my handwriting, of surfaces stay the same. See, this is a controlled variable, something that's kept constant. Then I realize this is my dependent variable. I want to know what is happening to it when I change what? The incline, which affects the normal force, which I'm going to call my independent variable, because that is what I, as the scientist, am manipulating. So I'm going to say to the marker, I understand that friction, I'll write it out in words, is directly or inversely proportional to the normal force? Directly. And we can prove it mathematically with a graph that is not only a straight increasing line, but a straight increasing line that passes through the origin. It must pass through the origin for it to be direct proportion. If it does not pass through the origin, it's just proportional, okay? One component or one aspect or one requirement for direct proportion, it must cut through the origin, please. So I say friction is directly proportional to the normal force. And you guys, please, I know I'm doing lazy things here because my handwriting sort of sucks, but you must write down friction and proportional, not prop, because that teacher who's marking your paper is not going to know what you're writing down. So friction is directly proportional to the normal force. Look at what I've done so far. I have mentioned my controlled variable, my dependent variable, my independent variable, and the relationship between the dependent and independent variable. When I am done doing so, I can now say what is going to happen to the normal force. And if you go and you enter it into your calculator, you're going to see that when this theta value becomes smaller, the normal force, or let's start with this, Fg perpendicular is going to increase. And when Fg perpendicular increases, when this force increases, what's going to happen to this one? It's also going to increase. So I'm going to state that the normal force is going to increase. So I say the normal force is going to increase when theta decreases. And in writing this down, I have explained why In question 2.4.1, we are going to say that friction is going to increase. Okay, so always, what you guys have seen me do, I always start off with the second part because that's how my brain works. I first need to analyze. But after that, I come to my conclusion, not based on my feelings. Guys, science doesn't care for your feelings, I'm sorry. You need to do it according to the principles, okay? You need to use these principles and come to a conclusion. Stop guessing, not because, we guess sometimes, but all of you are capable. All of you are here because you have capacity to learn this stuff and to apply yourself successfully. So stop guessing, make amends, and do this right in your exam, please. Okay. So we've gone through this. You guys now understand this can be called a level 2 question. They may sometimes call it a level 4 question. In my opinion, it's just a gentle level 2 question because it's so common that you guys answer it according to a certain procedure. Okay, it's understanding and you're applying yourself, and the more we practice it, the better we get at it. But for my people who like math, and there are many of you, guys love math, and it's good. But you need to understand that math is only one of the languages in which we communicate physics. We also from time to time use English in our South African exams. So you need to learn to express yourself in English as well, or you're going to lose a lot of your marks. Okay, so that is Newton's laws. There's so much more that I'd love to say on the topic. If you are struggling with any of it, I'd love to teach it to you, but we only have so much time. So I'm going to move on to vertical projectile motion. Okay, we're back on the Gauteng exam, the provincial paper that was written the other day. Okay. Some people love this section, some people despise it. Okay. Guys, what I have learned myself is that I tend to despise the things that I don't understand. So what is the difference between me getting it and not getting it, loving it and not loving it? It's just in my understanding. And it's a principle that can be applied with people as well. Some people do the wrong thing, they do the weird thing. But if you understand why they do it, you can start to tolerate them better. And it's the same with topics in physics. So if you do not like vertical projectile motion, my advice to you is go and study it. And study it and study it and study it until you always get those marks, and then you're going to love it. Okay? So, the first big mistake you guys make, you forget that this is about vectors, okay? This is not a scalar topic. The first 4 questions or so in your exam is vectors. So when we look at these beautiful equations of motion, on your exam, on your formula sheet, you're going to see that there are formulae with x's in them, and there are formulae with y's in them. If you're looking at vertical projectile motion, and I know the IAB sometimes tests horizontal motion as well, but please guys, if it is vertical, it is in the y-axis, so please make use of the formulae with the y, or we're going to penalize you and you're going to lose your beautiful formula mark. Now, on the note of pretty formula marks, please remember you only get your formula mark if you attempt to substitute into it. So do not think that you can just write down a formula and we're going to give you the mark. You have to attempt to substitute. I see some mouths open. I like this. It means I'm saying something you're hearing for the first time. I don't feel useless anymore. So guys, on the note of substitution, it doesn't matter if your substitution is wrong. Let's say you don't know what to do, but you have this feeling that this is the formula. Write that formula down, and then take information from the situation and plug it into it. But it's only if you plug into it that you're going to get a formula mark, okay? If you just write down the formula, you're not going to get a formula mark. Alright, now, in this formula, everything is a vector except time. Which means that when you are substituting, the initial velocity or final velocity, you remember that these are vectors and that direction is important. In physics, positive and negative refers to direction, okay? When we speak about acceleration, you guys know in this section that acceleration is 9.8 meters per second squared downward. And you decide what down is going to be unless we tell you otherwise. If you're going to make down positive, stick with it throughout the question. If you're going to make down negative, stick with it throughout the question. But unless we say what you must do, you decide. Just be consistent and remember vectors. Time, however, is not a vector, so we're not too worried about time. Displacement, this is also a vector. So please remember, direction is important. You're going to see on the summary page, I talk about time symmetry and speed symmetry and so on. I'm not going to go into those details because, like I said, my aim today is not to teach you the science, but rather how to answer a science question. So from here, I want to refer you guys to the problem. They say a tennis ball falls freely from rest from point A. The first mistake I noticed when I was going through my learner exams, and I take my little group of learners and assume that everybody's doing it, is that you guys read and you label, but you don't go and complete the pretty diagram that has been given to you. My suggestion is that you don't just highlight and say that this is V initial, but on your diagram where A is, go and write down that the velocity at A is 0. When we put things into picture form, we tend to understand them a little bit better. Then they say which is 44 meters above the ground, that would be our change in Y for the situation. The time taken to fall to the different positions is given in terms of T. T in this case was a variable which could change or which we had to determine, and they say it's shown below. So before we do anything else, we analyze the diagram. It falls from A to B in time 2t. It falls from B to C in time t. It falls from C to D in time 3t. So in total, it's going to take a time 6t. Sounds nice, eh? 6t. So 6t. All the way from the top to the bottom, 6t. Okay. Now, they said define the term free fall. Very few of my learners got full marks for this. I mean them no shame. The word that they left out here was not the word only, and it was not gravitational force. The word that they left out was this pretty word called motion. Okay, and I'm sure that lots of you have done that as well. Before before free fall is anything else, it is motion. Something is moving. So please, if you are looking at this, if you are highlighting, if you're making notes for you to go through later, guys, motion. Please don't leave that word out, okay? Second word people tend to leave out is the word only. I need to know it's only FG acting on the body, but that is why I say, learn your definitions word for word from your SAGS document or your exam guidelines. And guys, if there are any of you that do not know what the exam guidelines is, if you have never seen one, because I know it's sometimes like that. When I was in high school, I know it was long ago, but we never received that document and it hurt us. So please, let me know, send me an email and I will forward it to you, okay? But learn them word for word, please, so that you can get all of your marks. In the second question, they said calculate the value of t. To do so, you had to use the information given. If we chose down as positive, we make this our V initial. We make the displacement positive 44 and our time 6t. We could substitute into this formula, and find the value of t. But what a lot of people forgot is what t was. T was not the time taken to fall from there 44 meters down. T was simply a variable given over there. Okay, it was just a variable. So in the next question, and this is where things started to go wrong for most people, it said, calculate the height of the ball at point C. So this is what you guys did. You said, if we're looking at the fall from A to C, we know that this happens in a time of 3t. We would like to determine the displacement from A to C. We know the initial velocity, We know that the acceleration is 9,8 meters per second squared down. And you guys can see that I've chosen down to be positive. So we plug all of these pretty things into a nice pretty formula, and out comes a nice displacement. And then my learners stopped and they were like, I'm done, I did this. But they forgot that the 10,98 is not the height of C, because height, guys, is measured from the ground. Oops. The value that we just calculated is the distance between A and C. So if we are looking for the height, we have to say 44 minus the 10, whatever we found, and we determine the height above the ground. If you've made this mistake and you're kicking yourself in the foot, it's good, because that's how we learn. And that is why I'm using this document, because I'm trying to cause trauma. I want you guys to not sleep at night, because now you see all of these mistakes that you've made. Okay? Alright. Just, guys, you need to learn. And if you're going to fall and if your heart is sore, you fall forward. Don't fall backwards. You have to fall forwards. Okay? So, height, please read carefully. We love to ask for height in these questions, because you guys stop in the middle of nowhere. Be careful. Our aim is not to catch you out. Our aim is to ask science questions. But sometimes you guys don't understand the degree, how far you need to extend to answer the questions. Okay, so you would have gotten a mark for saying 44 minus the answer you got, and then you get your final answer. Please remember that the trial exams are a tiny percentage of your final mark. Your goal is to get that 75% in your final exams. And so there's no reason to cry for too long. If you're going to cry, fine, but not for too long. Whatever negative emotions you feel, you decide today, I never want to feel this way again, so I'm going to invest in my future, I'm going to study hard, I'm going to learn from all of my mistakes, and I'm not going to repeat them again. Okay, then guys, you have to draw a pretty graph. The only problem I saw with this graph, and I know a lot of you struggle with these graphs. Look, you're either going to get a graph of motion to interpret, or you're going to be asked to draw a graph of motion. So don't avoid them. If you are trying to get a distinction, you're trying to get a 70%, please don't avoid this stuff. You guys have time. You just need to use it wisely from today onwards. So here's the mistakes that I picked up. Some of you read through the pretty information. If after the first bounce the ball reaches point C, if after the first bounce the ball reaches point C, okay, sketch the position time graph for the ball from the moment it is dropped until it reached point C. What this means is we open our eyes, the ball drops, it hits the ground, it goes back up, and we close our eyes. Okay, it doesn't proceed after that. We just draw until it reaches point C. Now they give us criteria, and a lot of you left some things out. I want you guys to realize when they give you things in bullet point form, you need to go back and check. Did I do this? Did I do this? Did I do this? Did I do this? This question was out of 5 marks. We were looking to see, did your graph start at 44 meters, because they said the height at point A. We were checking to see if your graph passed point C at a time of 3t and at a height of 33,02. Of course, if you made a mistake in the previous question, there's positive marking, and you'll get your marks here for your 10, whatever. Okay, so over here we're getting 1 mark here, 1 mark at the bottom. It then goes back up, or it hits the ground at time 60, 1 mark, and it goes back up to C after its bounce, and then we get a mark for the shape. Okay, all of this information that is indicated is told to you. Show the following on the graph: the time values at D and C, time at D and C in terms of T. The height of A and C, height at A and C. Take the ground as the 0 point. Okay, it's all there but we tend to skip things when we're anxious. We tend to skip things when we're stressed. And I know that most of you are very stressed and anxious when you are in your exams. Yes, sir.
What if you put a space between the bounces?
You did this, am I right? You did this, and you gave time for the collision, and then it went back up. That's perfectly fine. As long as you indicated your time, that's perfectly fine. Okay, and also some of you flipped your axes, or you made your negative, your down, up, down. You chose down to be negative. Am I right? Or up to be negative. Up to be negative. And so your graph would look like this. If any of your graphs look like this instead, you guys will see you have got this with you. If your graph look like this instead, that's perfectly fine as well. You had a question.
How do you deal with those questions when they tell you that ball B was thrown 1 second after ball A, and the information the height at which they passed each other?
So you're talking about scenarios where you have to solve simultaneously. Okay, so a question is sometimes you get scenarios where there are two objects, ball A and ball B, and sometimes they're thrown simultaneously, or sometimes the one is thrown 1 second after the other, and those are questions you guys tend to struggle with. Can I do the following for you? Can I get a question like that, and then tomorrow I go through it with you? Is that okay? Yes.
For those simultaneous questions, can they ask a position versus time problem?
They normally don't, but if they do, they're challenging, and you guys must check to see, are they focusing on ball A or ball B? So guys, the question is, when you have these scenarios where there are two objects that are falling, or the one's thrown up and the other one is thrown down, can they ask you guys to draw Can they ask you guys to draw position time graphs, vector time graphs, and so on for those scenarios? Yes, they can. I have seen it before. So you guys need to get good at those. Alright, I'll look to see if I can get problems of that sort for both of you. Okay, are there any other questions? Yes?
So from 6t, right, if you make it reach the x-axis, do you use a mark?
You might. Okay, in my case I penalized my learners because it explicitly states that you need to draw up until C. So what my learners did is they let it bounce all the way down. I'm waiting for the moderator to tell me if I was being too strict. Okay. Any other questions, guys? I mark very strictly when it comes to the trial exams because I found that a lot of learners enter the exams very confidently, and then at the end of the year you were expecting to get a distinction and then you don't. Or you're expecting to get a 70 and then you don't. So I mark fairly, but I make sure that I'm strict. I don't know if that makes sense, but okay. Alright, yes sir. Okay, so the question is, let me make sure I understand you. Instead of writing 3t, you took that 0,5 multiplied by 3 and you wrote over here 1,5. Am I right? We didn't penalize you. Okay.